There is a structure in the universe so vast that even light, moving at 186,000 miles per second, would need 10 billion years to travel from one side to the other. Let that sink in for a moment. 10 billion years, a span of time older than complex life on Earth, older than our planet itself. This is not a single galaxy, not a cluster of galaxies, not even a swarm of millions of them. It is something far larger, something that stretches across a significant fraction of the observable universe itself. And the strangest part is that, according to some scientists, it shouldn't exist at all. That contradiction is what makes this story so fascinating, because it forces us to confront the possibility that our understanding of the cosmos might still be incomplete. Today, we are going to climb a ladder of cosmic megastructures, starting from our own neighborhood and moving outward, step by step, until we reach something so incomprehensibly enormous that it challenges the very principles on which modern cosmology is built. Along the way, we will encounter walls of galaxies stretching farther than light has traveled since the age of the dinosaurs. Invisible gravitational networks shaping the motion of entire superclusters, and mysterious alignments that may either be groundbreaking discoveries or illusions born from limited data. This is not just a tour of space. It is a journey into the limits of human knowledge. We begin close to home, at least in a cosmic sense, with a structure called the Laniakea supercluster. This is the vast region of space that contains the Milky Way, along with tens of thousands of other galaxies. From our everyday perspective, the Milky Way already feels unimaginably large, containing around 200 billion stars, countless planets, nebulae, and swirling arms of gas and dust. But in the context of Laniakea, our galaxy is nothing more than a tiny speck drifting in a much greater ocean of matter. Laniakea stretches roughly 520 million light-years across, which means that even if you could travel at the speed of light, something no physical object can do, it would still take you more than 500 million years to cross from one side to the other. That scale is almost impossible to visualize, but imagine stacking quadrillions of Earth-sized volumes side by side, stretching them across space, and you still would not come close to grasping its true immensity. What makes Laniakea particularly interesting is that it is not just a random scattering of galaxies. In 2014, astronomers mapped it by tracking how galaxies move through space, revealing that they are all slowly being pulled toward a region known as the Great Attractor. This acts like a massive gravitational basin, drawing everything within Laniakea inward, like water flowing toward a drain. It is a reminder that even on the largest scales, gravity remains the dominant force shaping the structure of the universe. But Laniakea is only the fifth structure on our ladder, and we are just getting started. The next stop takes us to a discovery so recent that it was only officially published in 2024. This structure is called the Quipu, named after the intricate knotted strings used by the ancient Inca civilization for record-keeping. The name is surprisingly fitting, because what astronomers found resembles a vast, branching network of threads stretching across space. Using detailed X-ray observations, researchers traced this filament-like structure across more than 1.3 billion light-years, making it over twice the size of Laniakea. What makes this even more remarkable is that the Quipu is not some distant feature at the edge of the observable universe. It is relatively nearby, embedded within our local cosmic neighborhood. In fact, it may be one of the largest structures in our immediate region of space, and yet we only just noticed it. The reason it remained hidden for so long is that it is incredibly diffuse, spread out over such enormous distances that its pattern is almost invisible without extremely precise data. It is like trying to see a picture formed by dots that are millions of light years. Part, you need the right perspective and the right tools to even recognize that a pattern exists. Scientists suspect that structures like the Quipu may play a significant role in shaping our observations of the universe, bending light through gravitational lensing and subtly influencing measurements of cosmic expansion. In other words, this newly discovered structure might already have been affecting our understanding of the cosmos without us even realizing it. From there, we move to one of the first structures that truly shook the scientific community. The Sloan Great Wall, discovered in 2003 through data from the Sloan Digital Sky Survey. This was not just another cluster or supercluster. but a literal wall of galaxies stretching approximately 1.37 billion light-years across space. To put that into perspective, if you tried to drive across this structure at a constant speed of 70 miles per hour without stopping, it would take you around 20 quintillion years, a number so large it is practically meaningless compared to the age of the universe itself, which is only 13.8 billion years. This discovery raised serious questions because it appeared to conflict with a fundamental assumption in cosmology known as the cosmological principle. This principle states that on sufficiently large scales, the universe should be homogeneous and isotropic, meaning it should look roughly the same in every direction without massive irregularities or clumps. Scientists had expected that structures larger than about 300 million to 1.2 billion light-years should not exist, depending on how they were defined. The Sloan Great Wall exceeded this limit, forcing researchers to reconsider whether their models were truly complete. It was a wake-up call that the universe might be more structured and more complex than previously thought. However, as impressive as the Sloan Great Wall is, it pales in comparison to what comes next. The next structure on our list has a name so exaggerated that it almost sounds like a joke: the Huge Large Quasar Group, or Huge LQG for short. Discovered in 2013, this structure consists of 73 quasars, the extremely bright, energetic cores of ancient galaxies powered by supermassive black holes clustered together across a region spanning about 4 billion light-years. That means light from one end of this structure began its journey before Earth even existed. And by the time it reaches the other side, our sun will likely have long since died. The sheer scale of this formation is staggering, but it is also deeply controversial. Some astronomers argue that the Huge LQG may not be a truly connected structure at all, rather an illusion created by how we analyze and interpret the distribution of quasars in space. These objects are incredibly far apart. Whether or not they form a single coherent structure depends heavily on how scientists define their boundaries. If the Huge LQG is real, however, it is more than 3 times larger than what the cosmological principle would allow, presenting a serious challenge to our current understanding of the universe. On the other hand, if it is not real, it serves as a cautionary tale about how easily humans can perceive patterns in random data. Finally, we arrive at what may be the largest known structure in the observable universe: the Hercules Corona Borealis Great Wall, estimated to span up to 10 billion light-years across. This structure would occupy roughly 10% of the entire diameter of the observable universe. That is almost impossible to comprehend, a single formation stretching across 1/10 of everything we can see. Yet this discovery is also the most controversial of all. Unlike other large-scale structures that have been mapped using galaxies or X-ray emissions, the Hercules Corona Borealis Great Wall was identified through the distribution of gamma-ray bursts, which are among the most powerful explosions in the universe. In 2013, astronomers noticed that these bursts appeared to cluster in a specific region of the sky, far more than would be expected by chance. They calculated the statistical likelihood of such a pattern occurring randomly, and suggested that it might indicate the presence of an enormous underlying structure. However, gamma bursts are rare, and the dataset is relatively small, leading many scientists to argue that this clustering could simply be a statistical fluke, rather than evidence of a real physical structure. If it does turn out to be real, though, it would fundamentally challenge the idea that the universe becomes smooth and uniform on the largest scales, forcing us to rethink key aspects of cosmology. Looking back at this journey, we began with Laniakea, our 520 million light-year home supercluster, a massive but still relatively modest structure in the grand scheme of things. We then encountered the Kipu, a newly discovered 1.3 billion light-year cosmic web hidden in plain sight. We crossed the Sloan Great Wall, 1.37 billion light-year, stretch of galaxies that pushed against the limits of what scientists believed was possible. We examined the Huge LQG, 4 billion light-year quasar grouping that may be either a groundbreaking discovery or a statistical illusion. And finally, we reached the Hercules Corona Borealis Great Wall, a potential 10 billion light-year structure that could rewrite our understanding of the universe itself. Each step along this ladder has revealed a cosmos that is not only larger than we imagined, but also more structured, more complex, and more mysterious. The big takeaway is that the universe is far from the simple, uniform expanse that early cosmologists once envisioned. Instead, it is filled with vast networks of matter, enormous walls of galaxies, and gravitational patterns that stretch across billions of light years. Every Tim.